All right, so we're going to do some of the homework problems, practice problems like you guys have asked. So I'm going to do a few problems here. So let me go in here and get started. All right, so let's see, we got a graph on here. So if the population is 2,000 people, what time of year is according to the graph? So I come over here to population thousands 2, I follow it over on my mouse, I hit the graph, I come down, looks like the answer is 1. So that's just reading the graph. Here's another reading graph. I'll let you do that one. So remember an equation for a line equals y. Let me get my pencil here. Y equals mx plus b, where b is the point 0, comma b, also known as the y-intercept, right? So by remembering those pieces, m is the slope, which is in front of the x, so that's 1/4. The y-intercept is a point, so you must put in the parentheses. The x value is always 0, comma, whatever the b value is, which in this case is -7. So if you just put in -7, that is not the correct answer. It's not a Hawks issue, which I hear a lot from my students and students I tutor. The correct answer, y-intercept is a point where x is 0, comma, b. Right, so don't forget that, because nothing's more frustrating than doing it and you think it's the software and you think you're right. It is a point. So growing linearly, it balances owed to credit cards from 700 to 1,200 in 12 months. So this is an exponential function where x represents the number of months that you would have a balance after 12 months. Well, it's in there cent, right? So x represents the number of months. What would the balance be after 12 months? So you put 12 in here. So when you type this in your calculator, I'm going to say it because I can't really show it to you. So you grab your calculator, you type it in all at once. You don't have to, you can do in parts if you want. But scientific calculators I told you to get can do this. So I'm going to type in 700 times parentheses 1 plus 0.096 close parentheses. You hit your exponent key, which is, again, on your calculators can look like 2 ways. It's either going to have this key or it's going to have something like this. Either one, find which one puts an exponent in. And then where x is, I just put a 12 and I hit enter. And sorry, I was trying to clear my drawings. And now I can type in my answer, 2102. I have 929, but it's money, so we're going to round to 2 decimal places. So 929 becomes 93. All right, so this is a good, just make sure you know how to type these things into your calculator. So now we're creating a function. So assume your salary is $24,000 per year and $90 for each computer you sell, right? What does the function represent of total pay for 1 year? Please sure to indicate any domain restrictions, right? So what does it tell me? Does it tell me to pick a specific letter? I was going to put function of x. So assume your salary is 24,000. So 24,000 per year. So times how many years we've been working there. Plus $90 for each computer you sell. Just restricted. You only for 1 year. So you get 2,400 is your intercept. If I hit it doesn't want me to hit space really. Plus $90 for each computer you sell for x is greater than equal to 0, right? Because you're not going to sell negative computers. You could sell 0 computers, or you can sell more. What does it not like? Yeah, that's the main. Right, what function you want to pay. I don't think I'm missing. So your salary is $2,400 per year. Write a function represent your total pay for 1 year. Do they really want x to be s? Is that the only issue? Really? You wanted c? So back to practice. Oh, I forgot a 0. That's what the issue is. I put 2400 as 24,000. I usually fix it when I make a mistake, but I'll leave it in to show as a teaching point to make sure that you are careful how you type in your numbers. So it wasn't that, as I forgot a 0 on my 24. I put 2400 instead of 24,000. All right. So we'll leave that in the video as a reminder to be careful what you type into your answers. All right, so this one we are going to cover next week, but I'll talk about it in the notes here. So we have to solve for b. So we basically have to go from logarithmic to exponential. So if you go back to our notes and I click on exponential, actually logarithmic, so 5.5, we have this relationship where I can move things around. So exponential form, remember y equals bx. The reason it's called exponential is because the variable is in the exponent. I can solve for x by moving it to the other side and then taking the log of the function, right? So if I rewrite this problem, drawings, right? So this is x, remember, and this is y. So I rewrite this thing as b to the third power, because that's where x goes, equals 64. Now it's a little bit of a guess and check, right? You have to know your cubes. What cube is 64? Well, 4 times 4 is 16, and then 16 times 4 is 64. So therefore, b must be 4. All right, so those are a little tricky because you got to kind of know the pattern. Remember your cubes and stuff. It should give you numbers, though, that we played with before, so it shouldn't be, should be a nice, straightforward number. All right, let's see if I try similar. Yep, so we'll do one more just so we can see here. Again, b to the 5th power is 32. I don't know my 5th roots, but you can think, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So therefore, this has to be 2. Okay, so for this one, I am going to shrink it down so we can see our formulas and quadratics. There's lots of formulas here, right? So to refresh here, I am going to put in my little text box so we can see these. So remember, our quadratic is ax squared plus bx plus c. So in this case, a equals -1, b equals 4, and c equals -3, right? So those are what our letters are. Our parameters are equal to for our formulas that we're going to do here. And when I don't want to use text box, no more I want to draw. So first, we're going to use the quadratic formula. And in this case, this was when this equals 0. So we're just going to say, hey, u equals 0, so I can do this first formula. And now I just substitute all these numbers into this formula. So I am going to get, let's see, b is 4. So I'm going to get a -4 plus or minus the square root of b squared. So 4 squared minus 4 times -1 times -3 all over 2 times -1. Now, I like to type this all in my calculator at once. So if I'm going to do that, I'm going to add a set of parentheses to keep my numerator together and a set of parentheses to keep my denominator together, right? So now I just go to my calculator and then I put in a parentheses, -4, and you can do it twice. You can do it once with a plus, whole thing, and then you're gonna do it again with a subtraction. So -4 plus the square root of 4 squared minus 4 times -1 times -3. Make sure you use the arrow key on your calculator to get outside of the radical sign before you put the parentheses in. Then I'm going to do divide, parentheses, 2 times -1 just is -2, so I'm just going to put -2 on the bottom. All right, hit enter. So the first value I get is 1. So x equals 1. So that is the point 1, comma, remember, because we put in a 0, so that's 1, comma 0. Now I do the whole thing again. So parentheses, -4 minus the square root, 4 squared minus 4 times -1 times -3. Push over on my thing, close parentheses, divided by parentheses, -2, close parentheses, and I get 3. So x equals parentheses 3, comma 0. So that is where the parabola crosses the x-axis, right? So now, what Hawks wants us to do, we have to put the vertex in first. We come down here and we have our vertex formulas. So for the x coordinate, it's -b over 2a. So for x coordinate here, this is going to be -b, so -4 over 2a. So 2 times -1 is -2. So -4 divided by -2 is just 2. And now what I do is I put 2 in for x up here. And be careful that you put this in your calculator correctly. Nothing's going to be more frustrating to you if you don't. That negative is not on the x squared. So this is going to be -2 squared, right? And that equals -4. And then I'm going to add 4 times 2 minus 3, and I get 1. So when I put when I put 2 into the quadratic equation, I get back this. So my vertex is 2, 1. So that is where the graph turns, right? And the cool trick is if A is negative, this thing has to turn down. So I'm going to go over 2 and up 1. And then these guys are going to come down here. So, right, because it's got A is negative, so I know it goes down. So now I can put my 2 x's in. So x is 1. So right on the line, and 3. And there we go. Right, so it's really practice putting these things into these equations. And make sure you have a calculator. You do not want to be trying to type this into a cell phone. You can do it in pieces if you choose to. I don't really think it's necessary. But again, it's what makes you comfortable. All right, so is a growth model supposed to? No, okay. So this is T years after June 1st, 2012. What is it? What's the population on January 1st? 2023. So how many years to 2023? So 2012, so 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 11 years. And we could have just subtracted those, but I know T is an 11. So I'm going to put 11 in everywhere there is a T. So again, 0.8 times 11 squared plus 6 times an 11 plus 21,000. Don't want to make that mistake again. And I get 21162. Round to the nearest person, so that's 0.8. So I'm going to go 63. Right, so it's a lot easier just putting into these different functions. This is a good one. Remember, we did one of these already, y equals mx plus b. However, this is not in the proper format. We need y equals mx plus b. So to do that, you must solve for y. So bring the 5x over, so you get 10y equals, so remember when you move things, you do the opposite. So I'm going to add 5x to both sides. So I get 5x minus 3. And then I divide everything by 10 to get y by itself. Make sure you simplify, type in the numbers that you get, right? So I get 1/2, because 5 over 10 is 1/2. Again, this is a point, I'm not going to do all the homeworks, but I'll do this one just because, again, I want to reiterate 0, comma, -3 over 10. So solve, if it's not in y equals mx plus b form, put it into y equals mx plus b form. Find the exact value of the given logarithmic. Okay, so remember, if we go, again, this is back to exponential, or maybe it's under logarithmic. Where do I put the ln's? There's my ln. So I can solve this by taking e to both sides, which cancels out the ln, right? It's an anti-log. So if I take e to ln and e to 46, e and the ln cancel, so that just becomes x. And you just go to your calculator, you find your e key. So it's there it is. So find your e key, and then make sure you realize that's an exponent, so it's e to the 46. No, I think they actually said the exact, so I don't want you to round. So you are literally going to use the keypad. You're going to put in e. It is raised to the 46 power. There you go. So you don't have to find e. So this is good. I'm happy I did this one. Make sure that you put in the e. There's the exponential, and it's always a power. E power is what we show here in the work. Annotate. Clear. Again, this one's just complete the table. So you see they've done some of them for you. So just put -1 in, 0. You can solve this one. So it's complete the table. Again, make sure you're careful how you put things into your calculator. All right, for this one, we are going to make sure we read carefully here. So let's see, record the sound and let's see. dB, if the unidentified sound is, so dB is decibels. So when we go to solve this problem, I have to do a little bit of algebra. So this becomes 67 equals 10 log, and then IO is always, in this case, is 1 because we're basing it off the intent, measuring at this basic, the foundation. There we go, can think of the word. So we're just going to call this log I, right? Because we just care about I. IO, we're going to have be 1 in this case. And for all of these in the tip prep, it should be, well, IO is just 1 because it's the starting intensity. Sorry. All right, so now solve for I. We got to divide both sides by 10. So I get 6.7 equals log, wow, okay, right all of a sudden, of I. Oof, doing horrible writing here. To get rid of the log, just like E gets rid of ln, 10 gets rid of log because 10 and log cancel each other out. So this becomes I. Again, you can review the notes for that. So this becomes 10 to the 6.7 power. So I go to my calculator, 10 raised power 6.7. And it wants me to round to the nearest whole number. So 5011872.3. So that's just going to be a 2. Now again, IO is 1 because we're starting as the entry level of sound. So we're really just solving for I in this case. Here's another one, figuring out the year problem. All right. So you purchase a car. So this is one like I just did like in class, right? So you can review the class video for this one. Another function, let's see if I can get this one right by typing it in correctly. So you, at least it tells our access there. You buy a refillable cup at a gas station for $9.50. They're offering you a special. You buy the cup, you can get a soft drink for only 30 cents for the entire summer, right? And excellent total amount you spend on the soft drink. So you spent $9.50 for the original cup. And you get, every time you take that cup back, it's 40 cents times each cup that you fill. So X is going to be greater than or equal to 0. So very similar to one I messed up earlier. Here's another one where you just put in the numbers. So let's see. I know the neighbor placed a bag of core kernels on his doorstep each morning. The first day, the bag contains 1 kernel. Second day contains 2 kernels, 4 kernels on the third day, and so on. Each kernel weighs 0.6 gram. How many will be on the 21st day? So this should be exponential, right? Because the first day, the bag contained 1 kernel. So 1 to the 0 power is 1. All right, the second day contained 2 kernels. Oh, it looks like it's going to be exponent of 2 because 2 to the 0 power is 1 kernel, and 2 to the first power is 2 kernels. 4 kernels on the third day. So 2 squared is 4. So there's our pattern, just like kind of that one problem in the first homework way back when we started. So this is day 1, day 2, day 3. So you can see our exponent is 1 less than the day we're on. So it should be 2 to the 20th power, right? For how many kernels? And then we're going to multiply that by weight at the end. So 2 raised to the 20th power is 1048576. It wants to know how much will the contents bag weigh. So we're going to multiply that by 0.06. So there's another fun pattern one. So 62914, round to the nearest hundredth, which is 2 decimal places. So write out the pattern, see if you can see it. And just remember, anything to the 0 power is that number. So we might have to start that way like I did. All right, so what it wants us to do here, it says graph the equation by looking for all the values between -2 and 2. So we're going to build our little table. So we're going to have -2, -1, 0, 1, and 2. These are all the points it wants us to plot. Right, now be very careful. The scales are different, are changed here. These are our x's. So when we put -2 in, so 3 divided by 4 times -2 plus 1 equals -1/2. When I put in -1, I get -3 divided by 4 plus 1 gives me 0.25. So 1/4. Put in 0, I get 1. Put in 1, I'm going to get 3/4 plus 1. So that's just going to be 7/4, right? Because 3/4 plus 1, so 4/4, 7/4. And then if we do by 2, that will become 3/2 plus 1. So 5/2. These in my head, so we're just going to check that one. 3 divided by 4 times 2 plus 1 equals 2.5. Yep. All right. So make sure we see here. That's 1, 2, 3, 4. So they count by 4, so that's good. So everything's going to work out here. So -2 here, down 1/2. So these are counted by 4. So I got to go with my pencil. My first point, -2, come down 1/2. That's 2 lines because they're counted by 4. So that's 1/4. That's 1/2. -1, I go up 1/4. 0, up 1. And they're lining up in a line, so that's a good sign. Over 1, up 7/4. So that's 1 3/4. And then over 2, up 2 1/2. Connect the points. Something don't look right here. This one might be too high. One of these is off because it should be a nice line. So let's check my numbers here. So 1 7/4. 7 divided by 4. 1.75. So I did that one in my head. No, that's right. All right. So that's 1. Oh, that's what it is, 2. I'm not over enough. There we go. Yeah, so they should have formed a line. So that's, if your line doesn't look straight, then it tells you one of your points are off. So carefully counting your lines. Then almost homework for you. There's a lot of good tough problems in here. That's using the quadratic like we just did before a minute ago. And there's another sound intensity. This one, you know how quiet it is. This is like the cat problem I did in class. All right, so I think we can stop there. I did a lot of this one. This is probably a little more algebra intensive chapter, so hopefully this video helps. Have a good day.